Now, application of Gauss theorem. Electric field intensity due to a thin plane sheet of charge using Gauss theorem. So suppose consider an infinite plane sheet somewhat like this. We are considering some small portion of it, and it is uniformly charged, and suppose the surface charge density of this thin plane sheet is sigma. Now let us imagine a cylindrical shape through this thin plane sheet to apply Gauss theorem and find out the electric field intensity. Now let us assume this to be of length say 2r, and this thin plane sheet is bisecting it. So say this part is till here, says r, and over here it's r. Now this area is represented as say ds. Same way this area is ds and this area is also ds, and let's place positive charge on this. Now as we can see, electric field through this edge would be somewhat like this, say E, and even the area vector of this ds is along this. Same way here electric field would be in this direction, and the area vector would be also in this direction. Now as far as the curved part is considered, the area vector for them is perpendicular to the direction of electric field. Thus the flux through the curved part would be E dot n cap, but E is perpendicular to n cap. Therefore the flux through the curved path would be 0, as the dot product would include cos of 90, and cos 90 is 0. Therefore the flux through the curved part is 0. So the only electric flux that we are obtaining over here is through the edges. Therefore the total flux over here is E n cap ds plus E n cap ds, which is basically 2E n cap ds, which we can also write as 2E ds, as angle between this electric field and the area vector of the edge is 0 degrees. Thus the total flux over here is this. Now according to Gauss theorem, we get the total flux is total charge divided by epsilon naught. Now the total charge enclosed by this closed surface is like the surface charge density sigma into this much area, which is ds. Therefore the total charge over here, Q total, is sigma into ds. Thus replacing this value in, say this is equation 2, this is equation 1. So replacing this value in equation 2, we get flux total is equal to sigma ds upon epsilon naught. Say this is equation 3. As we can see, equation 1 is equal to equation 3, both representing the total flux. Therefore we get 2E ds is equal to sigma ds upon epsilon naught, and ds get cancelled, and we get E as sigma upon 2 epsilon naught. So this is the electric field due to a thin plane sheet which is uniformly charged and infinite long using the Gauss theorem.